Okay, so you've done the defacement where you shot a vulnerability scanner and where they downloaded a defacement file. The next part that's interesting is a brute force attack. Although I mentioned the LeetSpeak domain, remember there's a domain called jumpingcrab.com and something like that. Yeah, it's still here. Cranking Glass or something like that. Make this bigger. All right. There. There it is, prankglassenebracket.jumpingcrab.com. So if you want, now, when you do find that an attacker has attacked your company and you find an IP address or a domain name like this, then you can find more from open source intelligence, which is easy to find. In fact, one thing to do is just work by the IP address. The IP address of the attacker is someplace here. Let me wonder if I hit this, it should lay things out, and there we are. Now I should be able to find the IP address. This is the web server address, and there's the attacker address, starting with 22 or 23. So what you do is just go to Google. This is an easy way to find open source intelligence. When you find that somebody is attacking you, just Google the IP address, and you'll see if it appears on blacklists. And there's a bunch of them: Threat Exchange, Threat Miner, Virus Total, RobTex. There's a bunch of people that accumulate open source intelligence. So try some of these. Threat Miner is probably going to be okay. And a lot of them accumulate the past history of that IP address, which is often extremely useful because people compromise a server and then they use it over and over again for different attacks. So that's not very interesting. Let's see if RobTex is better. IP info might be interesting, and RobTex might be interesting. Okay. Here we are. So it's an Amazon. Let's get rid of this garbage. Okay, it's an Amazon server, and there's where it is geolocated, but I would like the history of it. And some of these will give me previous domains that have been hosted there. There's Threat Miner, and here you go. It previously was Wayne Corp Inc. Here's some previous ones using it, but it only showed me 8 results, and there are others, so I have to keep looking. There used to be a better search engine here, and maybe I can find it. IP info, hybrid analysis. Now, unfortunately, a bunch of this is actually referring to this activity. Anyway, I used to pretty easily find one that would show you the previous history of that. Now it looks like it's harder to find. Let's see if I add threat intelligence to this. All right, here's recorded future. That's sponsored. Okay. Here we are. Here's the actual stuff. Virus total, possibly. Open Threat Exchange. And here's another Open Threat Exchange. Any run. Threat intelligence, Splunk. All right, maybe too hard to find now. It used to be easier. Oh, there we are. This is a good one. Now it's Level Blue Labs. I think it used to have a different name, but I recognize this. This is a page. This has a good historical list of all the domain names that have used this. And this is extremely helpful. You can very often tell what's going on from the previous attacks they've run. And here's the one that's in LeetSpeak. LeetSpeak is where you replace some of the letters with numbers. So here's Poison Ivy with some of the letters replaced with numbers. That's what they were looking for. This is the actual one that was used at the time this happened. So that's one information you get outside Splunk and open source intelligence to find the
what was that one called?
This one here, well, now it's called Level Blue Labs. It's Alien Vault. That's what I thought. They've given it some funny name, but it's really Alien Vault. Alien Vault has a good threat intelligence. So that'd be a way to find a good one easier. Yeah. And okay. Anyway, so let's go back here. So that was the domain name. Let's see, that was the LeetSpeak domain that it used. And we found the staging server IP. So now we're going to move on to the brute force attack because we haven't answered the question, how did the bad guys get our web server to make that GET request? Apparently, they gained the ability to control the web server to some extent. And here's how they did it. They did it with an IP address. So we're going to find the brute force attack. All right, so let me just make this split my screen here where I've got the Splunk on one side and the instructions on the left. Come on, there we go. All right. So I'm going to start over. Let's go to the top and just start a new search. I'll just hit the search to get a nice clean start here. And now I want to start with HTTP events. So I'll go to data summary and source types. Just to make life, and of course you can type everything in the text field if you know the format, but why bother since you have this nice GUI? Here's HTTP. So there's my HTTP events. Now I want to find the ones used in the post method. So what I'm going to do, I'm going to turn on sampling for right now because I don't need to see them all. I'll settle for 1 in 100 and then go to all time, because this will give me some HTTP events to start from. And now I want the ones using post instead of get. So that's going to be HTTP method down here. There it is. And see, there's post, get, and head. So all I care about is the post requests, which are the ones that send data like username and password and such. So now I found the post events, and they're supposed to be 15,570. And I have 157 because I'm only looking at 1% of them. So that seems right. Now I want to exclude the events from the vulnerability scanner. And the way to do that is like you would do it in Google, not and a word that you find in the vulnerability scanner, which is Acunetics. There are probably other ways to do it, but this is how I did it. I will exclude any event that contains that word. And that will greatly thin them out from 157 down to 3. So I might as well turn off my sampling now and see them all. There's going to be something on the order of 300 of them. Okay, 441 events that had a post and were not from the vulnerability scanner. Now, if I look at the form data down here, there it is, form data. I'll see the details of the request, and I see various different things happening here. So an easier way to see them all is to use this, make a table of them. So this will give me the time and the form data and nothing else. And that will be a way to focus in on just the most interesting information. And so now I'm seeing form data here. These ones had no form data. These had some kind of search going on. And if I go down to later pages of this, maybe page 3 or here by page 3, now I'm seeing the brute force attack. Username equals admin, username equals admin, username equals admin, and over here is password. Password is lifehack, Godzilla, and I'm not seeing there. Password equals Arthur, password equals 444. This is a brute force attack. Many attempts to log in with the same username with all different passwords, and they're coming in really fast, 50.6, 50.6. Several guesses per second. So this is useful information. Now, I want to find the IP address performing this brute force attack. So there's various things I could do, but my first concern is there was some stuff here that was not part of the brute force attack. There were some other things going on. One thing that seems real common to the brute force attack is it has this in it, username equals admin. So I'm going to just add that to my query. So I only see the ones that contain that. There, that should be the brute force attack alone now, and nothing but it. Now there's only 413 events. Now I can sort them by time here, and you can see what happened here. Right now, this sorting is not perfect. If you click this, it'll now be sorted. So this is, looks like going forward in time. So it started at this point, 10, 14, 45, 21.226, 241, 247, 250. It had like, what, 1, 2, 3, 4, 5, 6, 7, 8 guesses within 1 second. So this is a whole lot of, this is a brute force attack. It's a script trying many guesses per second of all these different passwords. and it's going to go on and on. And then if you go to the end of the attack, which I can do by clicking time again, you're going to see here's the script coming in with many guesses per second. Then the script finishes at 14:46:51. Then there is a 2-minute gap until 14:48, and then somebody logs in. And notice this login looks different than these. These have username, task, and stuff, and the passwords over here. This one has the username and password right there. So what happened is the attacker ran a script. The script tried a whole bunch of guesses until it found the right password. Then the attacker took that password and logged in a browser. And you can tell if you look at the user agent. So if I quit showing just a table here, and I look at the raw data again, I can go down here and look at the HTTP user agent. And you'll see 412 came in from Python, and then 1 came in from Mozilla. So this is the script trying all the passwords, and this is the user logging in to actually use it. And so there's a whole bunch of things you can answer now from this. You want to know the IP address performing the attack. You can do that by looking at the origin of these. And by the way, I think the IP address was different. If you look at the source IP, which is here, there are 2 of them. Again, the script was run from this address, but the interactive login from the attacker was run from here. So they used 2 different user agents and 2 different addresses, but this is the one that performed the brute force attack. Then you go down here, they'll ask you what was the first password used, what was the correct password, what was the time interval between the time it found the correct password and the time the attacker logged in interactively using the correct password, and what was the total number of passwords in the attack. So there's a whole bunch of things you can answer about that brute force attack using these kind of queries. So a useful thing to know. I'm going to stop this video. You can try that stuff.